this just in time. So, good evening, ladies and gentlemen. Gianluca Masi speaking from the Virtual Telescope Project, and today I will be only by voice here because I don't have a webcam here. I am in a different place than the one I suppose it to be to do this, but anyway, at least we have a very good audio and all the things we need to see the wonders of the universe live in real time online thanks to the virtual telescope. So friends, here we are for Stars for All, our online cosmic journey, just celebrating Global Astronomy Month 2017. So this is a very special event scheduled for such a very special celebration. You know, every year in April, now we have this month of global celebrations all around the globe, and all this is organized by Astronomers Without Borders. And I really want to thank and acknowledge the amazing work done by Michael Simmons, of course, Mike Simmons, and also his collaborators for making Global Astronomy Month a reality and really something special, making possible to people to meet thanks to the astronomy, thanks to the stars. And I always will repeat the amazingly beautiful motto of Astronomers Without Borders: one people, one sky. So really borders really go away, vanishes when you are under the stars. So using the stars to make possible to people to meet is for me a very wonderful mission. This is why the virtual telescope really supported Astronomers Without Borders since the very beginning, since the very first edition, and we will do this forever because we really want to be with them in this beautiful, important mission, especially these very days, you know. Anyway, tonight we will really surf the cosmos, we will go through space, we will really see a lot of things. I must say that the sky is simply perfect above the virtual telescope project. So I would say it is much better for us to be ready to live, just to use, to exploit this really wonderful sky. I also want to remind you that Global Astronomy Month is really offering a lot of things, so I strongly suggest you to visit www.astronomerswithoutborders.org to learn more about Astronomers Without Borders and in particular about Global Astronomy Month. Of course, I also want to remind you that all this is happening thanks to the Virtual Telescope Project, which I'm really proud to represent here, and that will make possible for you to live for this unforgettable experience. So we are ready to leave, and I really want to show you our spaceships. You know, the virtual telescope really is using two robotic telescopes. I am in Rome right now, while the telescopes are about 100 kilometers south from Rome, and nobody is there. This is a true robotic facility, and the telescope we will use, as we did basically over the last years, is the main robotic unit, the Planewave 17 inches telescope. This is a truly amazing state-of-art telescope. You see the optical tube and also the tuning mount from Software Bisque. And by the way, I want to remind you that we are here thanks to a few sponsors. They are Unitron Italia Instruments, Software Bisque, Badre Planetarium, Santa Barbara Instruments Group, and Planewave Instruments. I really want to thank for doing a lot of things for us and for making possible to be the excellence we are in the world. And looking around, our reputation is continuously growing. You know, a few days ago we had troubles because someone decided to hack our website just when we were really ready to host a big, huge, giant event. We had really tens of thousands of viewers in a few hours, and someone tried to really destroy our work, but we are still here, and we will be here until the the universe, the destiny will make this possible. Just to tell you that we were able to fix everything, you know. And it is now time for us to live for this fantastic online cosmic journey. So we are ready, friends. This is the the control panel of the telescope. I don't know why from time to time I'm really asked why I still use Windows XP. I don't know why I had to do something different if this is working beautifully. Our system is really fine-tuned to a maniacal point. It performs so beautifully that this system is just perfect. You don't change a winning team, and until this will work to the amazing level we see today, we will keep this. So we love this system anyway. So friends, I think that we can really start. You know now this interface better than me, I hope, if you are a long time friend of the virtual telescope. Basically here you have everything to control the system. You can ask the telescope to point somewhere, and then you can ask the camera to capture a picture for you. Being the telescope remote, of course, you cannot be there just to use this yourself. In other words, you cannot be there to put your eye on the virtual telescope console. In other words, this is the only possibility we have, just to see through the telescope. But all this, I want to underline this from time to time, it is happening in real time. You know what everything here means. There is the star map, that is basically the stars above the virtual telescope observing site, and in that map you see a yellow circle with a yellow dot in the center, and that is where the telescope is looking. So from every time, in every moment, if you look here, you can see in which part of the sky, in which very particular region of the heaven we are looking. So this long trip will start right now, and I really want to start you in a very great way, just spying together, just sharing with you something really amazing in our Milky Way. I will ask the system just to look for an object that we really love. Everyone with experience in astronomical observations should know M3. This strange name, just two characters, M, a letter, and 3, the number, just says what kind of object we are going to observe. You see that as soon as I asked the system about this object, another red circle appeared on the star map. That red circle is saying us where the object we are observing is. Oh, let's wait, friends. I have another idea. We will go there later, because I see that here, where I'm going to click, this is the good of real-time things. You can change in real time. Where I click it now, where you see now the red circles, there is the asteroid we observed a couple of nights ago. And I want to start from there because it is still very well visible, and I really want to share this with you, just in case you missed the original show. As soon as I asked the telescope to go there, the telescope just tell me that if I just want to confirm that if my real intention is to slew the telescope there. Of course, we are here for this, and you will see the yellow circle moving to the red one, and when the yellow and the red circles will be together, it just means that the telescope arrived at the destination we asked. And right now I just want to take an image, okay, of this, just to show you if there is something there. Of course, it is not obvious to spot the asteroid at the first glance, but we will do something just to be sure that the object is easy to find, easy to locate. So, a very quick exposure, a handful of seconds waiting, and the first image will show. It is just a raw image, and you see a number of stars around here, and okay. And let me ask the system to point again the asteroid, because it is moving pretty fast. And once we are there, I will ask the mount. Here you can see it here. This is a satellite, by the way. look here. This nice satellite just crossing the field of view. This is not the asteroid, my friends, because in a few seconds this is moving quite a lot, you know. So just enjoying this with you. This is not bad, friends. Every time something is happening there. This is an artificial satellite, of course, just crossing the field of view. We are sitting not far from the celestial equator where a lot of satellites are. And now what I want to do is to point the telescope to the asteroid, and then I will ask the system to track at the very peculiar rate of the asteroid, 2014 JO25. So let's ask the telescope to go there again, and as soon as we will be there, I will ask the telescope to track, of course, at the very, very specific speed of the system. Let's see, the asteroid will be one of the dots we have here, but now you can see a number of points of light here, but you cannot easily understand what is the asteroid. The only thing we can do is just to ask the telescope to take, let's say, a 30 seconds exposure, and during that those 30 seconds the telescope will track the asteroid. So the stars will show as very short trails, and the asteroid should be just a dot of light. This is a very nice, I will say, a very easy way to recognize the asteroids among the stars. This is particularly good when the asteroid is moving fast, so in a handful of seconds it moved enough to show against the stars. If the asteroid is very slow, it takes a lot of time to show it this way, and sometimes in that case other techniques can be much better. Anyway, let's have fun with this, friends. At some point I think we should be able to find, if any, well, I really don't see any obvious. Let's see, I have the suspect that the object should be this in the center, and let's see if at the next update, because 30 seconds are still too short now that the asteroid is leaving us and its apparent motion is slowing down continuously. But the next update should show the star moving a little and the object should be sitting there. Yes, that is the asteroid anyway. So let me ask the system again to take a longer exposure so that we can really see much better the motion. Right now, the distance of the asteroid from us is 0.07 astronomical units. If you want to translate this in kilometers, you just need to keep in mind that an astronomical unit is the average distance between the sun and the moon, and the sun and the earth, sorry. It is a bit less than 150 millions of kilometers. So if you just do this calculation, you will see that right now the asteroid is at about 10 millions of kilometers, and it reached on April 19 a minimum distance from us of 1.8. So it is more or less 6 times more distant now, because after the close approach, of course, it is moving along its orbit. Let's see where the asteroid is. I suspect it should be the bright point you see in the very center here, and with a longer exposure we should be able to see the stars much better. Okay, you can see now that all the stars around are visible like little trails, while the asteroid in the very center is 2014 JO25, friends. So we succeeded spotting this object. Also, I want to just change something in the software. I really like the idea that all this is happening in real time, and I just removed a name I used in some observations I did before starting this live feed. So I will wait for the next exposure. Then I want to show you an asteroid coming close in the next days. And just to show you that there are asteroids all the time around us, making them really important to study, especially if they just decide to come a bit closer than usual, friends. So let's see if this will confirm the asteroid is the bright dot close to the center. Absolutely, the stars are moving. You can see that the stars are moving to the bottom left corner of the picture. Anyway, so we start in a great way with 2014 JO25, which we already showed it in real time 3 nights ago, I should say, on Wednesday, you know. So let's stop this and let me look for another object, very small this time, another asteroid, and here it is. The asteroid is 2007. Do you see where the object is? Here it is. And let's ask the telescope to go there. 2015 HB1. And let's ask the telescope to go there, and you will see this moving pretty fast. So I asked the telescope to slew, to hit, and as soon as the yellow will be on the red, of course I will ask to track. I'll ask the telescope to track the proper apparent motion of that fast object, because you will see how fast this object is as soon as we will be there, friends. The telescope is moving, we are just there. And let's ask the telescope to track at the speed, apparent motion rate of this object. And now I will take a 60 seconds exposure, like the one we used earlier. And let's see what will happen. So again, after observing the 2014 JO25 asteroid, very popular a few days ago for its very safe close approach, it was a bit less than 2 million kilometers, so really not concerned. But it was 1.2, 1.4 kilometers large, and the great thing was that it was easy to see even with a binocular, okay. And now we switch to another object, 2017 HB1, and this guy is coming tomorrow, April 23, at 14:55 universal time, at about this one is coming 24 of April, so 2 days by now, but 0 at 9 and 7 universal time, so more or less in 1.5 days this object will be at 3.6 lunar distances from us. As you can easily see now, something changed, because this object is moving much faster than the one we observed earlier. So in the same 60 seconds, you see the motion is much more evident, to the point that this object here is just leaving, is just forcing the star, if you want to track it, to leave much longer trails. I suspect it will be much better to use a longer exposure. It's just a 2-minute exposure. This one is a relatively new object. I want to check on the Minor Planet Center website and see, to give you some details about it, just to be sure. Here it is. This object has been discovered by the Pan-STARRS survey. No, sorry, it has been discovered by Mount Lemmon survey, even if I see that it was discovered on April 18, but the discovery circular issued by the Minor Planet Center is showing observations coming from the Pan-STARRS survey 1 day here, several days earlier. See, some of them were late on March, and at the time it was extremely faint. and they missed it, and it was discovered by the Mount Lemmon survey just April 18, you know. And as I said, this will have a safe close approach with us next 24 of April at 9 and 7 minutes universal time. It is a very small rock, more or less 20 meters. It is a bit larger than the small asteroid which exploded in the atmosphere above the Chelyabinsk city in Russia in 2013, February 2013. And as I said, this is coming more or less 3.6 times the distance of the moon, and I can just convert this right away for you. It will be 1.4 millions of kilometers, a bit closer than 2014 Geo 25 a few days ago, but this is really much more smaller, you know. It is 100 times smaller in diameter, more or less, just to give you an idea. And let's wait for the first image we are just grabbing here, and we have the object, friends. The object is this small dot of light you see in the center. Do not consider the little dots you see on the left, because those are warm pixels coming from the digital device in the silicon detector. This is typical for charge coupled devices, digital imaging devices, you know. And you will see in 90 seconds, more or less, when this will update, that the object, the only dot surviving, should be the one in the center. I mean, if you see a dot of light just inside, you see the red circle. This is helping a lot. I mean, this is easy to see. That is the small asteroid I wanted to show you. The telescope is really tracking this object thanks to the very advanced mechanics we use from Software Bisque, the Paramount MA, which is truly a piece of art of mechanics, electronics and software. I really love it, and I want to thank Software Bisque for helping us to get their technology as part of the Virtual Telescope project, you know. I'm just waiting for a few, more or less 50 seconds, just to show this to you, the object, you know. I hope that so far you are having fun with us. For us, it's always a pleasure to celebrate Global Astronomy Month, and the Virtual Telescope makes possible for everyone, even for those far from any physical event, to join something on their side. And for me, this is important, so that the Global Astronomy Month can really be global, you know. And I was checking, okay, I see that everything is coming with very high quality. I'm very happy. And let's see what will happen in a few seconds. New image coming, and let's see which dot will survive. And yes, the dot is the one in the center, as I told you. So happy that in real time we are looking this small 20 meters large rock coming close, and its close encounter is expected for in the morning, in the European morning of April 24, when it will be at 1.4 millions of kilometers. Needless to say, this is much more than a safe close encounter. Just fun, no worries. Really, you don't need to worry. Don't worry about this at all. So I think we can stop there, this, because we had a very good experience. And now let's try with the object I was ready to show you at the very beginning. Do you remember Messier number 3? Now it's time. Here it is, Messier number 3. We are not far in the sky. Of course, this is just an apparent, proximity, because the asteroid is very close. The object we are going to see is very far. It is just perspective, you know, and perspective can be really, really funny sometimes. So ask the telescope to go. So going there, you see. And the telescope is now at destination. I will just take a short exposure, and then I will ask the telescope to go with that 2-minute exposure, and this way we will exploit the object at its best, you know. So this is taking a quick exposure. If you see some delay, it is simply because the console you see is just traveling through the network, you see. And this is the wonderful globular cluster Messier 3. The telescope is taking images back to back, and now I really want to take a longer exposure. I asked the telescope just to adjust a little the position, and let's do this. This is Messier number 3. This is one of the most popular deep sky gems you can see this very season, okay? And this one is also very bright, to the point that you can see a dim object, a fuzzy object, if you look at its position, even with a small telescope. It is a globular cluster. We have a bit more than 100 globular clusters in our Milky Way, and they are very huge families of stars with a lot of stars, very old stars by the way, and they are not inside the spiral structure of the galaxy, but they are all around the spiral galaxy, embracing it from the outside in what we call the galactic halo. And this one was discovered by Charles Messier, hence the name Messier 3, the third object in the Messier catalog, and it was discovered on May 1764, you know, and because Messier was a great astronomer, French astronomer of the 18th century. And if you look here, just while we are waiting for the next image, you can see how those stars are very close to each other. Don't consider the strange pattern you see because the telescope moved while the system was taking an image, because I asked the telescope to move. But in 30 seconds we should have a very perfect image. I love that we are doing this together right now, friends. And Messier 3 is truly a gem, as I say to you, and it is not close to us because this object is about 30,000 of light years far from us. So it is so distant that if you really want to express its distance in a comfortable way, you have to use light years. That is, considering how fast the light is moving in the vacuum space, empty space. Light is traveling at 300,000 kilometers per second. In 1 year, you do 10,000 billions of kilometers. But if you want to go that fast to this object, you have to travel for more than 30,000 years. The other side of the medal here is that we are seeing this object not how it is now while we are enjoying Global Astronomy Month. We are seeing it how it was 30,000 years ago, because the light coming from that big amazing cluster needs the same amount of time to reach us, like the light from us reaching it. And you can really see how dense the stars are in this cluster, to the point that the telescope can have a very hard time resolving the central regions. But here the very sharp eye of the virtual telescope is making possible for us to see even also the very center of the object. And this is something I really love, because our system has a truly fantastic resolution to show many details, even in very critical, very crowded and dense globular clusters like M3. Just waiting for another image coming. and then we will leave this for something more distant. I will do back and forth, inside, outside the Milky Way. This is the good when you just live for these journeys with the Virtual Telescope project, you know. Well, the image arrived, it is basically the same, so we did not notice. But you see, if I push, on the contrary, the system to show even the faintest stars just burning the core, you can really see how large, okay, these objects are. Look how many stars are here, friends. Sorry. Okay. I'm just trying to see. This is the same image, okay? I'm just adjusting in real time the thresholds of the displayed image, you see. So you can easily see how rich is this object, you know. Because if I just used the thresholds to display the image, to leave the core in a very nice way, readable way, you were going to miss the faint peripheral regions. While now we are able to see how large, how big this object is, but of course, to save the faint peripheral regions, you are just burning the core. But let me say, this is the same image. Just I have to decide which kind of information I want to extract from it. And this is why I love digital imaging, because this way a single image can really have a lot of information, and you can decide which part of that information you want to study. Now we are just waiting for a handful of seconds just to save another image here, and then we will move to another gem. Here it is. Okay, the system really updated the image, but now I'm going to stop this, friends. Let me show this full screen just for your own joy. I will also adjust the system so the object will be in the very center. And here there is also a galaxy. I really love how looking up in a given direction, you see everything you have in that direction, from a mosquito to a distant galaxy in that direction. This is just perspective, you know, and how beautiful is this. Now let me try to adjust. Okay, I just want to be sure that we have an image with these thresholds. And now let me see if I can just make the core a bit more comfortable to see. Okay, I will stay with this. We love this really nice globular cluster. Messier number 3. Time to say goodbye to it, and a new image is just coming. If I try to abort, let's see if the image, okay, stop it. So let me try for another Messier object. Messier number 663, which is not far from here. You will see where the red circles will show respect to the yellow ones. Yellow where the telescope is, red where the object is. So let's ask the scope to go there. We are just moving there, and we are there, and I ask now the system to capture a quick image just to be sure. Okay, let me do this, by the way. Not sure that I just set up it properly, but let me try. Oh, we have something, you see. Let me see, the system should automatically put the object in the center. This is what I wanted. And now I just minimize this and ask the system to go with a 2 minute exposure. This is our magic number, 2 minutes exposure. But what about Messier 63? This is a galaxy, and I decided this is a galaxy, also named this is a sunflower galaxy Messier 63, and I decided to show this to you because a couple of days ago they reported the presence of a supernova inside this galaxy. It was faint, it was reported several days after the images were made, and now we discovered that that supernova, and it is indeed a supernova, is not part of that galaxy, but it belongs to a galaxy which is behind, but much more distant than that. So it is a very nice effect of perspective once again. Let me see if I can show you again this object when the final image will arrive. I managed to take images of this. By the way, let me see if I can prepare the image for you so that I will show you the image I did, where of course the object is also evident. Okay, let me find where the image is right away while we're waiting for the image to show here. Look at the beautiful galaxy we are seeing right now, friends. This is Messier 63. This is a galaxy, so this is another Milky Way. We are very far now from our home galaxy. With Messier number 3, we were 30,000 kilometers far, but still in our galaxy it's halo. Now we are 1,000 times more distance, because this galaxy is about 30 millions of light years. And if I adjust here the contrast, sorry, I can try to show you where the supernova is. I will also show you, of course, an annotated image just to be sure that you will see. Oh my god, I just used the zoom in a too easy way. Okay, we are back, and now let me put the original scale, and then let me try to adjust the brightness and contrast so that I can show you where this supernova is. And it was reported just 2 days ago. I'm just, as I did for the globular cluster, I will put in the very center a very faint star, okay? That is the... You can see in the very center there is a very small structure here, that is the supernova. And now I will show you the image I did earlier, yesterday I must say, with our telescope. Here it is. So you can see the image is rotated 19 degrees clockwise if compared to what we were seeing with the telescope, but just to show you where the faint star is. And also because this was very faint, that we understood that that supernova could easily be in a galaxy far behind Messier 63. Okay, you can always have a lot of intergalactic dust, okay, just absorbing the light of the supernova, even when it is hosted by the galaxy. But here we were able to spot that its redshift, which is a good way to measure distances in the universe, is much more larger than the Messier we have in the foreground. So this is a really amazing superimposition. It is just a perspective effect. This is for me just funny. So with that image in mind, I will show you again the live image I'm receiving from the telescope. And now in the center there is the faint object, of course, which is the supernova that we caught live thanks to the virtual telescope during our Stars for All Cosmic Journey Online as part of the Global Astronomy Month celebrations, friends. But let's go. We have still several things to see. Just waiting for a third image, because these images will be useful anyway for me to study this supernova. So happy that they are coming here. And I'm also using another telescope, but the telescopes part of our system are now running for some scientific needs. Anyway, let's close this and let's move to see something belonging again to the solar system, friends. I want to show you one comet. Comet Johnson, you can see it here. This one was discovered 2 years ago. Chislesh 2015 V2. And let's ask the telescope to go there right away. Very nice. This is a very nice experience. I see I aborted here because I want to use the same system I used it earlier. So the telescope will move. Oh, sorry. I did something wrong here. My fault. And I just clicked on the wrong place. The lag we have with the internet sometimes. I want to go to run faster than the internet, but here the internet speed rules, you know. Okay, this time let's do this better. So the telescope now is going to Comet Johnson. And we will see a very quick, very poor but still interesting preview. And then, as we did earlier, we will go with the longer exposure. Of course, 2 minutes. You can see there is something here, possibly a comet, you know. But I will put this a bit off center, just to be sure that we can have some of the tail present. So I also asked the telescope to check how fast the comet is moving among the stars, so that I can be sure that the telescope will track the comet. I asked the telescope to do this right now, and let's take now a quick exposure, okay, because I had to close the previous one. Okay, and then I will start the longer exposure. Okay, let's close this. And let's start the deeper images, Okay, for now we have this, and you can easily see that a comet is something very diffuse. You see there is something bright here, and there is a large, you see, a portion, okay, very diffuse, as I said, quite fuzzy, and that is the coma of the comet. Sometimes you also see a nice tail, but this comet is not showing the tail. As I say to you, this is a very quick image. So the next one should show this much better. But this is, as I say to you, Comet Johnson. We are waiting for the long exposure just to enjoy this better. And as you can see, I decided to move the telescope a bit just to have the comet on the bottom part of the image, leaving enough space for its coma on the upper part. And this is comets are objects I really love, and exactly 20 years ago, April 1997, we had the legendary comet, Hale-Bopp. And right now we are 15 seconds far away from the next deeper image of this comet. So we will see much better its coma, I believe. You see everything here looks white simply because we were on the shorter exposure, the preview exposure, but with a click I will recover from this. And look now how you can easily see much better the structure, the tail. You can see going from the condensation, central condensation of the comet, just going on the upper left. Not bad. Comet Johnson imaged real time as part of our Star for All online cosmic journey to celebrate Global Astronomy Month 2017. Very nice image. Of course, you can still play a bit with the thresholds here, brightness, contrast, something like that, just to make sure that you can possibly find a fair choice, just showing this. In less than 1 minute I will have a second image. I want to wait, so at least we will measure a position and send this to the Minor Planet Center. So observations done during this live journey will be used for science too, of course. The Virtual Telescope is a truly amazing facility, making possible science communication and science at the same time remotely. I can also control all this from my smartphone, and this is a pocket telescope, if I can call it that way. Truly nice Comet Johnson. And as soon as I will have this other image, look here, let me see if I can just put this full screen for you, as I used to say, for the record, Here it is. At least we can just enjoy this elegant visitor of our solar system, Comet Johnson, live as part of this journey from the Virtual Telescope. I will close this and also stop the other images, and now I will try to show you another great thing. Back to the Messier catalog. Another galaxy. So we started from very close. We observed near asteroids. Then we left for a globular cluster on the border, on the outer regions of our galaxy. Then we jumped to another galaxy. Then back to a comet, so in the solar system. And now, once again, let me see if I can go away to visit another fantastic. Okay, let me do this. I forgot what I wanted to do. Here it is. And then ask the telescope to go yellow to red, you know. This is slowly moving. And we are reaching Messier 51. Everyone knowing something about the sky really love the galaxy, because it is a galaxy, as I said, we are going to see. You will see just the preview how beautiful this galaxy is. Wonderful, to say the least, you know. So I just minimize this, and I want to ask the telescope to go with a longer exposure, of course. Let's start it right away. Started. And let's put again this to the very center. Okay. Look, this perfect spiral structure. This is Messier 51 Whirlpool galaxy, but as you can easily see here, it is not a single galaxy. They are two, and you can let me see. I'm just using such a very short exposure, and this is already amazing. You see, I find this so wonderful. And with this we are at about 25 millions of light years, sorry. A bit closer than the previous one, you know. But I'm looking forward to see here the final image, the one we are waiting. We should have soon, in about 40 seconds, you see. Messier 51, one of the most beautiful deep sky objects you will ever see in your life. I cannot remember how many times I saw this galaxy, how many times I imagined it. I told you, this is something really extraordinary. Really love it, and soon we should see this in its full glory. Again, everything white, because we regulated on a short exposure, a longer exposure, much more signal. But here we are. Let's start this way. But wow, from an extreme to the other, if you look here, you can likely see only the cores of the two galaxies. I really love this. Let me see if I can discover with you this. I selected the system, I asked the system to show me the brightest parts of the galaxy. Of course, it is their nucleus. But if I slowly go and ask to show the fainter and fainter, at some point you start to see the arms of the galaxies. Look how beautiful is this. In a couple of minutes we really were able to capture this amazingly beautiful object. It deserves the full screen here. Let me see if I can also limit. Okay, too much, I see. Okay, let's continue. A new image will arrive soon to overwrite what we have here. How beautiful, friends. Look at the elegance of this. Love it. Enjoy how one arm of the spiral, the big spiral in the center, is really connected to the satellite galaxy on the left. I really love this one. Messier 51, the queen of the spiral galaxies, the Whirlpool galaxy. And all this live thanks to the virtual telescope from Global Astronomy Mount France. Not bad, I believe. So let's close this and let's close our live event with another globular cluster, the king of the globular clusters we can see from the northern hemisphere. Again, a Messier object, the number 13 this time. Ask the system where number 13 is in the Hercules, and in fact Messier 13 is also known as the big Hercules globular cluster. Ask the system to go. This time I remember the right button I had to push, so the yellow is now going to the red, and then we will observe this object. Of course, we will automatically have a preview to enjoy, but this time, I know this is brighter, I will use a shorter exposure. I just prepare. Okay, sorry, the telescope of course was faster than me, and even the preview is clearly saying this is much more impressive than Messier 3. Okay, let's ask the system, as I say, to go with 60 seconds. Meantime, you can still enjoy the richness of this object. How many stars? There are hundreds of thousands of stars all together here, packed together, I would say. This is very, very beautiful. I love it. The distance of this is about 25,000 of light years, while the linear distance of it is about 100 light years. Amazing, isn't it? I just want to wait here for the long exposure. In a few seconds, I see. And then I will use it to play a bit with you. Here it is, the image, the longer exposure is just downloading. Much more signal, I see. How beautiful every time we go with something beautiful as this. We are truly impressed, my friends. I want to put this full screen again. And first of all, I want to show you how large this object is, much more than Messier 3. Also remember that here I used half of the exposure for Messier 3. There we used 2 minutes. Here I just collected light for 1 minute because this is much brighter. Really love it. Really love this object. At some point, if you take a long exposure, this will almost fill the field of view. Look how large, much more than you could suspect actually, you see. Same image, just different thresholds. But let's look inside it. Okay. Click by click, I simply want to just to jump into its heart. Amazing. Also, the image quality provided by our telescopes is breathtaking, you see. This is a raw image, no image processing at all. All the images you see around are heavily processed. With this really great quality, even in the raw image, you can easily imagine what we could get. If you visit the Virtual Telescope website, you will find in the gallery cluster section, you will find one of the best, an epic image of this object that we did. Of course, carefully processing it. I really like this one. And with Messier 13, we had a big chance, a wonderful place to end our journey, you see. I really am speechless. Amazing. How can you stay without emotions when you face the wonders of the universe? Amazing. So, I think that we really had a great time with our live cosmic journey for Global Astronomy Month. I hope that you had fun. I hope that it was worth your time, and I also hope to be able to reschedule the online Messier Marathon. Unfortunately, this month the weather has not been the best, and I also have to admit I really had a lot of things, a very busy month for me. So I will do my best to reschedule it. So far we had working on the moon. We also spied the Asteroid 2014 JO25 for Global Astronomy Month, and tonight this. Let's see if we will be able to save, of course, the online Messier Marathon. But for now, we are ready to close, to say goodbye. For me, Gianluca Masi, it was a big pleasure to be your guide through the universe, which we explored live with some of the most intriguing objects, very peculiar supernovae, near-Earth asteroids, comets, galaxies, globular clusters. So we had really nice collection of gems to enjoy, to unveil the beauty of the cosmos. So continue celebrating Global Astronomy Month, and I also invite you to visit the www.virtualtelescope.au website. We also have a Facebook fan page. You can easily join there if you want to stay up to date about our activities. That's all, friends. I hope this was a good experience for you. So I thank you again for coming. Thank you for your time. And again, take care. Keep looking at the stars.